and we'll get started here. All right, so it says vibrations on the surface of a planet occur as a result of the movement of the various layers of the planet's crust. A recent geological study found that the frequency of vibrations in Denmark had a value of 0.2 hertz on Sunday, and that they were directly related to the frequency of vibrations in Paraguay. Brad, a Russian seismologist, noticed that the frequency of vibrations in Paraguay on that same day was 0.1 hertz. On another day, the following week, the frequency of vibrations in Denmark was found to be 1.36 hertz. What frequency can Brad expect to be found on the same day in Paraguay? So I think we looked at a question like this last week. Do you recall that?
Yeah, this looks similar.
It's really similar, yeah. And so the key thing here is this word directly. And why don't you give yourself a moment to see if you can solve it. It's okay if you can't, but let's just take a look at it. While you're doing that, I'm gonna just pull up some other materials for us to work on. So go ahead and take a shot at that and I'll be right back with you.
Okay.
All right, how are you doing on this question?
I kind of remember how to do it, but not super well.
Sure. So there's two equations here that are related here. Direct variation y equals kx and inverse variation y equals k over x. And this is what, if you had a reference sheet or something that you could bring on the exam, that's what you would want to bring with you here. Of course, this question isn't as simple as just, hey, write the direct variation equation or the inverse variation equation. What it's asking you to do is take a look at this sentence right here and combine it with this sentence, the second sentence here. So it says everything kind of very directly. It says Denmark had a value of 0.2 hertz and it was directly related. So we could write Denmark is directly related to Paraguay. And I like using the letters of the countries whenever possible. So we have the values. We know that in Denmark, it's 0.2, and in Paraguay, it's 0.1. And so it's kind of as a numerical skill here, are you comfortable, because this is no calculator, this section that we're working on, are you comfortable, dividing decimals? Okay, now they wouldn't be so complicated that you can't do them by hand, but this is the kind of thing where you should be able to reasonably attack here. So k has a value of 2, and you put that back into the original equation. You have d equals k times p, but now k we would replace with the value of 2. And then from here, there's really two types of questions they could ask you. They can either give p and then you find d, or they could give d and you could find p. So if you look back at our question, okay, if you look back at our question, they give you the Denmark 1.36. It's the second case here. This is the one we're doing. So they tell you that it's 1.36 equals 2p, divide by 2, and you get 0.68 hertz. So there's nothing in this question that you can't do. You know how to write the direct variation equation. You know how to solve for the value of k, and you know how to rewrite it and solve for the other value.
Okay.
So I want to give you one just like this, different numbers, of course, and it's going to be in the 2-column format because that's what you're used to seeing on these exams here. And this problem is problem number 3 out of the weekly practice set that is included that you've got a link to. So you can practice this question all week, as well as work on some practice tests. But go ahead and take, I'll check with you at minute 11 of the hour here, and just go ahead and see if you can work this one out on your own, please. How are you doing on this one?
Good.
I'm just going to start working out the solution here in case you have questions on this later. Okay, so did you get letter D as your answer?
Yes.
Okay, perfect. So I've been giving you about 3 minutes per question. Have you talked about that in some of your previous classes about time and its impact on the exam?
A little bit, yeah.
So our goal is actually to be able to do a problem like this in 1 minute. And
Mhm.
one of the ways that you can achieve that is obviously through just practice, doing as many problems as you can. But what most students notice is that, and if I were to make a little graph here of the time. So if I give you a problem that you've never seen before, usually you can't solve it. So we'll just say you can't solve it. But then once I've worked through it and you've done it a second time here, it takes you about 3 minutes. And by we'll say the third or the fourth time working through it, somewhere you actually get down to about a minute pretty quickly when you start doing the problems. Again, so I'd like to do one more, have you do one more of these. And this time it's the exact same type of problem, same numbers, I'm sorry, different numbers, but the goal here is to do it as fast as you can. So this time I just want you to tell me when you're done, and then we'll just see how quickly you were able to complete it. So let's see here. Yeah, okay. Actually, this one's slightly different, but it's still a good test. So let me snip this one in. All right, are you ready?
Yes.
Okay, so go ahead and get started here. Let me just frame this a little better. All right, go ahead and get started there, please. Let me know when you're done.
Okay. Okay, I'm done.
All right, very good. So that was about a minute and a half, which is great. It just every time you do the problem, you're going to do it faster and faster. What answer did you come up with?
I got B.
B is correct. Excellent. So as part of the practice sets that you're going to get every week, one of the first six questions are multiple choice, and then the last four are free response. And one of the things that, as you know, the part of the exam is free response, where you have to fill in the bubbles for your math section here. So I want us to look at question 7 here. Again, it's the same style of question, but this time, there's no answer choices. It's just you filling in those bubbles with the correct answer. So let's do one more. Let's have you practice one more, and then we'll move on to something else. So give this one a shot, and so let's see what you come up with.
Okay.
Do you have an answer for me?
Yes, I got 0.46.
That is correct. Very good. Okay, so if you see a question like this now on my materials, you'll obviously know how to do them, but again, that direct variation and inverse variation is something that you might see on the test itself. So I'd like to move on to a new problem. Is there
Okay.
anything you want me to any follow-up on this, the last few questions we've worked on? Anything you have questions about, or?
I don't think so. I'm good.
Okay, great. Now remind me, do you want us to look at a question, or do you want me to cover the skill, kind of the math skill that goes into the question first? Which would you prefer?
If we could cover the skill first, I think that'd be great.
Okay. All right. So the next question has to do with averages. You might think, well, I already know how to do an average, and absolutely. So let's just say I asked you to find the average of three numbers like 75, 78, and 84. Okay, and it might seem like you need a calculator here, but you actually can do these without one. That's not the point here. The point is, you know, how do you find the average? Well, you add up the three numbers and you divide by the number of numbers. That's pretty straightforward. Okay, so if I add another one here, like if I go up to 80, or I put a 90 here, maybe you would divide by 4. Okay, and you're never going to get something that simple on the SAT. But what you will be asked to do is, for example, and I'll make these numbers smaller. They'll tell you that's the 7, 8, and 9, and they'll say, well, what's the fourth number, such that the average is I don't know, make it something like this, like 12. Okay, so they say the number's missing, and but the average of these four numbers is 12. How
Okay.
would you go about starting something like that? What would you do to attempt to solve that? Go ahead. I didn't catch that. I'm sorry if you said anything, I didn't hear you.
Oh no, I didn't say anything. I
Okay,
don't
okay,
really know.
okay. So here's approach one, and this is kind of what the classical approach. So what a student would do is they would say, okay, it's 7 plus 8 plus 9 plus x divided by 4, and this needs to equal 12. Okay, and so to solve this equation, hey Julia, let me know, are you back?
Yes.
Okay, so if you're seeing my screen, what I'm trying to show you is what, like, this is the classic approach, and this approach here is where you add up the scores and you divide by the number of scores, and that equals your average. And so my question to you is how would you solve this equation? How would you solve for x? What would you do first?
Well, you would try and like, oh my gosh,
I mean, you
I've
could
forgotten
get
like all my algebra.
you could guess the number, but that wouldn't be right here. How do you clear the fraction? What do you multiply both sides of the equation by?
4.
4. So you multiply both sides by 4. And so on the left, it's 7 plus 8 plus 9 plus x equals 48. And then you would add these three numbers together. which is 24. And then you would subtract the 24. And x equals 24.
Okay.
Okay, so let's try another problem here. Let's say you were working on you have some tests throughout the semester. So you got an 80 on your first exam. Your next exam was 85, and we don't know the third exam grade, but your average is 89. So this time you're going to add up these three numbers, including the missing one. So you would divide by 3.
Okay.
Now, if you want to grab a calculator, use one while we're working together, that's totally fine. But I want to show you some ways to do it without a calculator, because there will be some times where you're going to say, for speed, you're going to want to do it this way. So when you clear the fraction, when you multiply both sides by 3, okay, you have to look at 89 as 90 minus 1, because 90 times 3 is 270. And then minus 1 times 3 is negative 3. So that's 267. And so there's some shortcuts that we're going to talk about during our time together here, that and this is one of them. It's like you've got to be able to do this type of math pretty quickly.
Okay.
Because it just gets in the way of doing the rest of the problem. So 80 plus 85 plus x equals 267. What do we do from here?
Okay. Once you clear the bottom,
Yes.
then you add 80 plus 85.
Right. And then you have to be able to subtract. And so that's another skill here, that you want to be able to do stuff like that very quickly. So the score is 102.
Okay.
All right, so let me have you try one on your own. Any questions on this before we on these two examples before we do another one, or have you try one on your own?
No, not so far.
Okay. So let's say 20, 23, 25, and x, and the average is 30. So go ahead and work that out, please.
Um, 52.
52 here. So here's how I'm going to check. 20 plus 23 plus 25 plus 52 over 4. All right, so these two make 43 and 77, and that looks good there. So yeah, that gives you so that's the correct answer there. Perfect. Okay, now I want you to look at these three examples again, but I'm asking you a different question here. Here it is. How did the value of x, so in our first problem we did, what was the value of x that we ended up finding? You see how it's 24 down here? How does it compare to the other three numbers? So I remember I said, okay, here's 7, 8, and 9, X. The average is supposed to be 12, and you found that X was 24.
Mhm.
What could you say about this number compared to these three numbers?
24 compared to 7, 8, and 9.
Yeah. And there's nothing, it's not a deep, I'm not asking for something deep here. It's just like, what do you, with observationally,
Um,
how does the size of this number compare to these numbers?
it's a lot larger.
It's a lot larger. Let's look at the next example here. We started with 80 and 85 and X, and we wanted to get to 89, and X ended up being 102.
Mhm.
So what do you notice about this number compared to these two numbers?
Um, yeah, it's a lot larger.
It's a lot larger again, right? This was intentional. What did you notice about 52? So we started with 20, 23, 25, and X. I wanted an average of 30. X is 52. It is also a lot larger.
Mhm.
So notice that if you want to raise the average, okay, you need a large number. So here's why that's important, because there's some questions on the exam that you can actually answer without doing any calculations. It was something like, if and I'll just shorten it, if the numbers 4, 3, and 7 and X are given, and we want an average of 10, okay, and there'd be more words to it, but here would be your answers, your answer choices potentially. And let me actually get the right answer here. So the correct answer is, let's see, 14, 26. So the correct answer is 26, but here might be some of the other answers. 10, 16, and I'll just throw, let me just put these down here. So let me do this, just change this, just grab this one here. Sorry, it's not doing that. Okay, I don't know why it's doing that, but here are the answers. Okay, and we know because we've been working a bunch of these problems, we know that the number has to be a lot larger than the other numbers.
Mhm.
Okay, and there's a strategy on the exams too, for example, to like try the numbers. Well, you would want to try something, and notice in all of the cases that we did, this number was a lot larger than the average.
Mhm.
A lot larger than the average. So we would immediately exclude, potentially say they can't be that one, can't be that one. And so
Mhm.
let's say you try 16 and you realize this is wrong. You might be able to immediately say, oh, that's correct.
Okay.
So I'm going to try to point some of those things out along the way as well when we see this. So if we were to summarize this question, the answer generally is a lot larger than the other numbers when we're going up an average. But we could do the same problem here where, let's say I give you the numbers 4, 3, and 7 and X, but this time I want the average to be 2. So this time the average is smaller than all the numbers. So if we work this the same way, 4 plus 3 plus 7 plus X divided by 4 equals 2. What did you notice that you were doing every time in these problems? What did I call this step? Do you recall?
Um,
Where we get rid of,
you were you multiplied by 4?
yeah. So every problem you clear this fraction.
Mhm.
And the reason is because that's what the formula says to do. Another little time savings thing here is to actually multiply the right-hand side, the average, by the number of numbers. And this is one of those time savings things, is you generally deal with sums not averages on these standardized tests, meaning you don't really care what the average is, you care what the sum is. The sum is these numbers added together. It is the average. See, this is the average times the number of numbers. So rather than writing this, what we really want you to write, 4 plus 3 plus 7 plus x equals 8.
Okay.
And notice you're not writing this, you save time there, and you're doing the calculations, you're already kind of stepped into it. So this is 14 plus x equals 8. So x is -6. This may be uncomfortable, but you can use negative numbers. Because I didn't give you any context. I didn't tell you like, oh, we're counting the number of cars that pass by. So it's okay that the answer is negative.
Okay.
So let's try another problem here. Let's try to look at this idea here. Let's say you scored 80 and you got an 86 on your next exam, and we really want to retain. Actually, let me change this slightly. Grades are usually kind of a good one to and let's say you want your average to remain at 80 because you get a B with a grade of 80. So first thing you should say to or ask yourself, you say, how many numbers do I have here?
3.
And 3. So this time multiply this number by 3 because that's the sum. Okay. And then you have 82 and 86. And you can write this, that there's nothing wrong with that, but we really want to save as much time as possible. So 82 plus 86, 168 plus x equals 240. So what does x equals? 72.
Okay.
So notice we save time by doing this. If you can add the numbers rather than writing them out, that also saves time. But let me have you work on some problems here, but I'm going to keep the numbers small. So this is your first problem to try on your own. So let's say I give you the numbers 3, 5, 4, and 7, and x. And this time I want an average of 2. Try working that out, please.
X equals -9.
X equals -9.
Yes.
All right, so let me just add these up here. So like when I add another thing you can do here is you can try adding, like that's 10, that's 9. So we have 19 plus x equals 10. So yes, x is -9. Perfect. Okay, so let's try another one here. Let's say a person got exam scores of 68, 73, and we need the third exam score, but this time they're trying to get an average of 70. Go ahead and give this one a try, please.
X equals 69.
You said x equals 69. All right, so that is correct. Yeah, perfect. Okay, so we finally have enough here to start to look at, let me copy it in here. This came out of, I think, the initial practice thing we started working on last week. But let's take a look at this question. I'll read it out loud and you just follow along. 2 students take a math placement test as part of their fall semester orientation. The test must be taken in the N building on campus and takes about 50 minutes to complete. Taylor has already taken the test twice and received scores of 76 and 68. Her best friend Ken already placed into Math 107 after taking the test 3 times, receiving scores of 72, 75, and 93. Taylor has just received the score from her most recent attempt. If her average score for all 3 attempts is 77, what was her score on the 3rd attempt? So if you need to, I want you to try working this one out on your own, but if you need to read it again, keep in mind there's a lot of extra information here, and that's because the concept is relatively simple, which is averages. Averages they're never just going to ask you to find the average of 3 numbers or 2 numbers. They're always going to ask you to do something with it. So I'll check in with you at 43, minute 43. Okay. And just see how you're doing on this one. All right, how are you doing on this one? Hey, Julia, how are you doing on this question here?
I got D87.
Okay, let me just work it out here just in case you want to look at this type of problem later. So again, there's a lot of stuff that we don't care about. Basically, this is the information we care about: 76 and 68 and 77. So it's really similar to the questions that we were looking at earlier. where we know the average is 77. Since there's three numbers, you'd multiply this by 3. So to do that quickly, it's 210 plus 21, or 231. And if you can add these numbers together quickly, that also helps. 148 plus x. And then, like you said here, actually, did I do something wrong here? I added incorrectly. It is 144. So yes, the answer is 87. Let's try one more problem like that. Did you find this was easier since we'd worked out kind of the math behind it?
Yeah.
Yeah. And it's because there's not two of you, there's no way to know. But if you had seen it without seeing the math, I wonder if you would have been like, well, I have no idea how to do this. But it's really not too difficult. All right,
Mhm.
go ahead and try working this one out on your own, and just let me know when you get your final answer.
Okay. Is the answer D, 80?
Let's see here. Sounds correct. 79 plus 87 equals, so we got to take 82 and multiply it by 3, so that's 246. And these add up to 166 plus x. Yeah, so it looks like the answer is 80. All right. So my lessons are a little shorter in the summer. If you have time, so we're going to close out here. If you have time, I would definitely recommend working on that weekly practice set from Monday. Just doing a couple of problems here and there. They're reviewed from what we did. But the main thing I'd like you to focus on between now and tomorrow, if you have time, is the practice exam number 1.
Okay.
It's okay if you're not able to solve any of the questions or you're not sure about how to solve them, but just give it a try. And the more effort you put in, the better I'll be able to help you, because we'll be able to better figure out what you are sure, what you know and what you don't know, and all those things that go into getting the best grade possible on this test. So that email links to everything that that I'd like you to work on this week. But we've got a lesson scheduled for tomorrow at I guess 1 p.m. and
Mhm.
I will see you then.
Okay. Thank you so much.
You're welcome. Talk to you tomorrow. Bye now.
Bye.